Good day, everybody. Welcome back to another episode of Wildcard Workshop. Today we're going to be talking about interface blueprints. Not user interfaces like we were talking about in the last video, but these are a communication system for blueprints to talk to each other. And this is going to be a bit of an interesting video. The reason for that is because during all the time that I spent modding, interface blueprints turned out to be one of the most useful things that I'd found. The reason for this is because when we're making mods, we don't always have control over how the game is implementing things. So we jerry-rig a lot of our systems into place, and this can lead to problems, particularly where references are concerned, when we have files that are trying to talk to each other back and forth in sort of this closed little loop ecosystem, and we run into problems with things like circular references. Interface blueprints can help us keep that under control, and they can also allow us to do some really interesting things in terms of communication between mods. So I'm going to start out by talking about the intended use of interface blueprints. And then we're going to talk some about how we can use it with mods that might be considered a bit more unorthodox. So let's go ahead and dive into the dev kit, and I will show you how it's done. Alright, so here we are in the dev kit. Now, these project files are going to be a little bit different than we've done in some of the previous videos, just because trying to set this up in an actual mod would be rather time consuming. So instead, this is going to be an editor only project. One thing to keep in mind is that this particular setup will not work in a dedicated server environment. It wasn't set up that way. I feel like it would have convoluted some of what I was trying to get across with interfaces. So I just kind of left that out. So when you mess with these project files, just make sure to turn off run dedicated server here if you have it on. So let's look at what we've got. If you open up the project files, you will find this test map area copy here. You can go ahead and open that up. And what you'll find in here is you'll find a bunch of statues sitting there. And you'll find there's this box here, this trigger volume. Now, this trigger volume has some code attached to it for the purposes of testing this out and debugging. And basically all it's doing is if you come down here into details after selecting it and find trigger volume in level blueprint, you'll find this section of code right here. Okay. Basically, when the player character overlaps it, it gets the reference to them, spawns this test control actor instance, attaches it, and sets the owner to the player. Now, this test control actor is just sort of an interface. Gotta avoid the word interface here. This is an actor that will capture our input for the purposes of this example. Okay. So there's two keybinds in here. The way this works is on begin play, I put a little delay. I get the owning player controller for this actor instance, and then I enable input on it. And what this does is this enable input puts this actor at the top of the input stack. Okay. That allows for us to capture key input. I've got it set up for G and H. Okay. So before we continue any further, let us pop into Pi, and I'll kind of show you what we're doing here. Okay. So go ahead and hit play. Once you're in game, go ahead and move over the trigger volume right here. This will attach that actor. Now, if we look at either of these objects here, okay, these are two separate classes. I didn't put any custom functions on them in a parent class. But what you'll see is, I'll hit G. Oh, look, it changed color. And I can keep hitting G and it'll keep getting bluer. And for this one, I'll hit G and it'll get greener. Now, if we go over to these other statues, you'll notice it doesn't do it. Okay? These ones are set up for a different example. So this is our example of the common usage of interface blueprints. Okay? That one is a slightly different, more unorthodox example. So let's focus on this one first. So these are just two classes here, a table and a vase. Obviously this is not a vase. I was going for something else when I was making these files, but I just didn't change it. So pretend that's a monkey vase. Just roll with me. Just roll with me. Okay? Now, each of these, you'll notice the parent class is actor. Okay? Now, I haven't made any changes to the actor class. And then there is also this iInteractable blueprint here. This is our interface blueprint. And to create an interface blueprint, what you do is you come down here into your content browser, you right-click, you go down here to blueprints, and you find blueprint interface. What that'll do is it'll generate this file. And if you remember from our last video, this file is just to declare function signatures, okay? And what I mean by a function signature is we're giving it the name and we're telling it what inputs and outputs to expect from it. And that's it. You cannot edit the graph itself in these blueprints. It is just a declaration. There is no implementation involved here. What we do with a function blueprint, or excuse me, with an interface blueprint, is we go to any actors or objects, any classes that we want to implement it. We find this button up here. It says Blueprint Props. We come down here and we scroll down. Oop, wrong one. Components, Blueprint Props, and Implemented Interfaces. You just come down here and you select it from the list. When you add an interface, it will add the function declarations to that class. Okay? Now, there's two kinds of function declarations in terms of interface blueprints. There's ones that do not have an output and ones that do. Ones that do not have an output defined can be used as events like this. If it does have an output defined, it will show up here on the left, just below all of the overridable functions. Okay? Where you will be forced to implement it. Event doesn't have to be implemented. It can be ignored if you don't want to actually use it. You shouldn't do that, but it can be. But ones that have a return type or an output defined, they must be implemented. The class will not compile unless you do. Unless the return type is like a single type that can zero out on a value, like a float or an int. But if it's an array, for instance, it'll error out when you try to compile it. So, we have both the table and the vase implementing this iInteractable interface. And all that's here is just this interact event. On both of them, it adds a dynamic material instance to the mesh, and then it changes the color parameter on that material, which you can find up here. Color matte, MIC, color matte test. Now, in the vase, it makes it more blue. In the table, it makes it more green. So they have slightly different implementations of the same event. the way this gets called, once this test control actor has been added to my character and the input has been enabled, it gets the owner controller, it gets the player camera manager, and then we do this thing here. This particular thing is not necessarily explicitly required for interfaces, but for a lot of the common uses of interfaces, they usually involve player interaction. Line traces are useful for that. What we do is we grab the player camera manager, we get the camera location, we input the camera location as the start, we get the camera's forward vector, which is the direction that it's pointing, basically, and then we multiply that by a magnitude of 1,000. That's what we're doing, is we're telling it that's the direction and how far, okay? And then we add that to the player camera location in order to say how far, direction, how far, and from where. And that'll give us our endpoint. And what this line trace does is, you remember when we were in Pi, you saw those red lines? What it does is it draws a line from the start point to the end point. And the first thing that it collides with, collision is important here, the first thing that it collides with, depending on its object type, it will return a result that has it, and it'll return information on what it collided with. This is how a lot of things like opening doors or interacting with the primal structures in game operate with user input. So after we've got our collision, we grab our hit actor, and then we call the interact interface message. Now remember, to call an interface message, you right click in the graph, you go down to interface messages, you find your interface blueprint in here, iInteractable in this case, and then you add it to the graph. Now we don't actually need to do that because it's already there, but this is what we do. So to recap, what's happening is I press G. It draws a line in front of the camera, point in the same direction the camera's pointing, and the first thing that that line collides with, it tries to call this interface message on. Now you notice we were trying to call this interface message on classes that don't implement it as well, those other statues for instance. Nothing happened. And that's because interface messages don't care what type of actor or object they're being called on. If that class does not implement the interface, it fails gracefully and discards the message. Nothing happens. If it does implement it, it'll call it. So in the case of our vase and table, this event will fire, and this code will get called. So we can look at that again, now that we kind of have an understanding of what's happening. So once we're in, remember, walk over to the trigger volume to get our actor, our input actor, and then boop, and see there's that line. That is the trace from where we were looking. See that? Okay. That's how a line trace works. Okay. And when it collides, that's what that little red square is. That means it found a collision and returned at that point. Then it returns that, and we're calling that interface function on it. And it's just getting bluer and bluer. Or greener and greener. So this is the, more intended purpose of interface blueprints. Okay. It is a way of adding common functionality to multiple disparate classes and object types that don't share a common parent or common functionality. This is also to note how the charge system works that was added in Aberration. There is an interface blueprint for that, and this is how it works. Okay. I mean, it's different interface functions, but this is essentially how it works. You get a reference to whatever objects are around, and then you try to manipulate them using that interface blueprint. Now, for the not so normal interface usage. So when we're making mods, we often have a problem that crops up eventually with references. And we're trying to make all of our classes talk to each other in such a way that it creates a hard reference between them. And we get circular references, and we get problems when we're trying to compile. Blueprints won't stay compiled. This is also often what happens with function libraries, is because when you define something in a function library, like a class or something, it adds that class to it. But then when you call any function in a function library within a class, everything referenced by that entire function library gets added to that class as well. So this leads to unintended circular references as well, and then eventually you find out your function library is loading up without, it's saying it's dirty the instant it's loaded up in the kit the first time you open it. And that's a sign right there that you've got some circular reference issues. So we can actually use interface blueprints to keep that under control. So we have 3 classes right here. None of them actually know anything about each other. Okay? Just like those 2 over there, each one is a child of actor. They're all sibling classes. See, parent class actor, parent class actor, parent class actor. This one has a different function interface than the 2 of these have. So let's look at what happens. Okay. I'm going to do a singular button push, okay, after I get my actor right here. All I'm going to do is push H, okay? I'm not touching the keyboard anymore, but you'll notice it's still doing stuff. And what's happening is this actor right here, when I pushed H, I triggered a function on there, and then it got references to these 2 classes by asking for a list of all actors that implemented an interface. And then it called another function on them. But it did this without knowing anything about these classes. Now after that, after it triggers that color change, one of these is doing a similar thing where it tries to get all actors of another class that's implementing a different all actors that are implementing a different interface. And that gets it a reference to this actor, which it's then resetting the color, and then after a short delay, it's triggering the color cycle again. Okay? So we've got all of these blueprints talking to each other without having any knowledge of each other's classes. Let's take a look at that real quick. Oops. So we have 2 interface blueprints right here this time. We have iColor Commander, which is kickoff, and the functions are kickoff color chain and reset color. Okay. In iColor Changeable, there's a change color function. If it'll open, there we go. And all that's on this one is that there's an input for a linear color struct. Okay. So if we look, let's start from the beginning of the process again. Let's open up our test control actor. If we go to the graph, down here under H, here's what I do. I get all actors with interface. This is a node that you can use. And I tell it, give me all the actors with the iColor Commander interface. Now, something special you can do with these interface messages is you can give it an entire array as the target, and it'll automatically do a for each over them. You don't have to do the for each yourself. It'll do it itself. But keep in mind, it is definitely a for each loop that is occurring when you do this. And that will be more apparent when we look at the other classes really quick. So we come back in here again. We go to command statue. Okay, this is our color. This one implements the color commander interface. Okay. So once we've got this one, we've got two events in here. For event kickoff color chain, that's when I press the H key. It gets all actors with interface for iColor changeable. Okay, so everything that is implementing iColor changeable, which is these two classes right here, and there's an instance of each on the map, it returns an array. Again, we're using the entire array into this color change, but you'll notice I'm giving it the same struct. And this is how you know it's a for each loop, is because the way these kinds of nodes work, these pure nodes, every time this function is called, these will be called. Only then. These don't get called before it. That is a visual error that can be easily made. So keep that in mind. Every time this function is called, all of these are going to be called again. And this is called every time, for every instance in here. It's called separately. So each instance is actually getting a separate color because these randoms are being called again. And that's why the two statues had different colors every time it was called. Now on our statues here, they're both doing something slightly different again. They're doing the same thing with the color as each other. Okay, and this is very similar to what we were doing on the other actors during our more orthodox. The color is just an example type thing. We're just setting a dynamic material instance to the mesh and then changing the color parameter on the material. But in statue 2, there's a delay after it finishes that color change, and then it does a get all actors with interface iColor commander and calls that the reset color interface function on it. So now we've gone right back to the command statue down here where it gets all actors with interface again on that implement iColor changeable. It resets the color back to black. It waits 5 seconds and then it does the color change interface function again on everything that implements iColor changeable. So, as you can see, they're continuing to talk back and forth with each other. Now, this is a bit of an unrealistic example in terms of there's not a whole lot of reasons. I mean, there could be reasons to want to have sort of this color shifting dynamic changes going on in your map. But the point of this exercise was to show that there is no hard references between any of these three statue classes. They know absolutely nothing about each other. The only things that they know about are these interfaces. Now, something to keep in mind. When you are using your interfaces, when you define these types, make sure that you are not setting them to specific class types in your mod. Because then you're just coming into the same problem again. You are giving this interface the knowledge of your mod classes, and then you're implementing the information, the interface on your mod classes, and then they're getting that chain of references coming back again, and you'll end up with a loop. When you choose your input and output types, make them generic. Okay? Actor, or primal structure, or primal item, if you do want to limit the types, try to make them as generic, as high on that hierarchy chain of inheritance as you can, so that they are more malleable. And then afterwards, after that data has been passed to a class, then you can do a cast to whatever type you need if you really want to do that. Or you can try to call a function on them or something like that, okay? But this will prevent you from creating a lot of unintended references between your separate classes. Now, something else to note is there is another unorthodox usage for interfaces that you can do. Now, remember how I said the only thing on these is a declaration of a function signature. No implementation. Well, you can make your interfaces available to other mod authors to give a way for them to interact with your mod without having to give out all of your implementations and private code. If you give out your interface files, you got to make sure that you are also giving them out with the entire directory structure for your mod, because it's basically like for declaring that, this class exists. So if I wanted to release these two interfaces here, I would have to make sure that people knew that in the mods folder, there's this interface lessons folder, then there's the not so normal usage folder, and then the interfaces are inside of that, okay? Or you can package it up like that, where it's with only those interface files in the folder structure that's required for them. Because if they're in a different folder, they're actually considered a different class. So you got to make sure that you're careful of that if you decide to do some experimentation working in that. Interfaces can be really useful and it can allow for some really creative things. Gazlol, he used interfaces to allow for people to make decorative packs for his auction house. So different maps can now have different appearances for his auction house. I used it extensively in ArcFrame in order to keep different references under control, because it was a massive system, but the method of implementation was a bit limited sometimes because of how it had to interact with base game classes. There are probably numerous other ways that you can make use of interfaces as well that I haven't even considered yet. But this is how you use interfaces. You just add them to the classes that you want to implement them, and then you can call them. And you do not have to give them specific references to that type of class. Okay? This get all actors with interfaces, all this returns is an array of references that are all cast as the type actor. Interface messages do not care what the type of an actor is, or what the type of a reference is. If they don't implement it, it's discarded. If they do, it's called, and it does everything in a safe manner. My hope is that this will help a lot of people that are having trouble with those references issues that we spoke about get that back under control and are able to do a lot of the things that they were hoping to do, but found that those issues were cropping up and they didn't know how to get around them. But as I mentioned before, I will include these project files so that you can play around with them and look at them. Remember, this isn't set up for a dedicated server. I'm sure there may probably be questions about some of this information in the comments. Feel free to ask. Hopefully, all of that has helped you come up with some interesting ways to reorganize your mods so that you don't run into some of these problems with references and blueprints trying to talk to each other in chaotic and uncontrolled ways. And also maybe some ideas on how your mods might open up for interaction with other mods as well. This may not be a realistic dream, but eventually I would love to see like some kind of repository of all of the different interfaces of mods, and people picking and choosing which mods they want to take interaction with and things like that. Or maybe just a singular mod that adds all of the interfaces of different mods together, like one big mod API. I don't know. Yeah. In any case, that's all for this video. Until next time, happy modding.